Hi guys, what's up? This is Sir EJ and welcome again to another math tutorial. In today's topic, we will be discussing the interior angle of a circle. So we have the following objectives in today's topic. At the end of the lesson, the students should be able to letter A. Determine the relation among arcs and interior angles of a circle. Letter B. Find the measure of arcs and interior angles of a circle. And letter C. Value accumulated knowledge as means of new understanding. So let's have the definition of an interior angle. So when we say interior angle, it is an angle that can be formed by two chords or two secants that intersect inside of the circle. So in figure number 1, this is an interior angle formed by two chords. And in figure number 2, this is an interior angle formed by two secants. So let's now have the interior angle theorem. So the interior angle theorem states that the measure of the angle formed by two chords or two secants is equal to 1/2 the sum of the measures of the intercepted arc. So if we will find the value of angle 1, we will use the formula angle 1 is equal to 1/2 times the quantity of arc AC, which is the intercepted arc of angle 1, plus arc DB, the opposite arc of angle 1. And then if we will find the value of angle 2, we will use the formula angle 2 is equal to 1/2 times the quantity of arc CB, which is an arc opposite of angle 2, plus arc AD, which is the intercepted arc of angle 2. So let's have our first example. So we have a given circle. So the measure of arc AD, the bigger arc, is equal to 129 degrees. The measure of arc BE, which is the smaller arc, is equal to 71 degrees. So we will find the measure of the two interior angle of the circle, which is angle BXE and angle DXE. So to solve for that, we will construct a formula. So we have the formula measure of angle BXE is equal to 1/2 times the quantity of arc AD plus arc BE. And then after that, we will substitute the corresponding value. So bring down angle BXE is equal to 1/2 times the value of arc AD is equal to 129 degrees plus the value of arc BE is equal to 71 degrees. And then we will simplify. Bring down angle BXE equals 1/2 times 129 degrees plus 71 degrees is equal to 200 degrees. And then 1/2 times 200 degrees is equal to 100 degrees. So the measure of angle BXE is equal to 100 degrees. So how about the measure of angle DXE? So to find the measure of angle DXE, we will subtract the measure of angle BXE by 180 degrees. Because this is supplementary, the sum of the angles is equal to 180 degrees. So 180 degrees minus 100 degrees is equal to 80 degrees. So the measure of angle DXE is equal to 80 degrees. So let's have our second example. So we have the following given. The measure of arc AB is equal to 52 degrees. The measure of the interior angle ACB is equal to 40 degrees. So we will find the measure of arc DE. So let's have the solution. So we will construct our formula. The measure of angle ACB is equal to 1/2 times the quantity of its intercepted arc, which is arc BA plus arc DE. Then we will substitute the corresponding value. The value of angle ACB is equal to 40 degrees equals 1 half times the value of arc BA is equal to 52 degrees plus the value of arc DA is unknown, which is equal to x. And then we will simplify, bring down 40 degrees, and then 1 half times 52 degrees will be equal to 26 degrees. 1 half times positive x is equal to 1 half x. So bring down 40 degrees, transpose 26 degrees, it will become negative 26 degrees, equals bring down 1 half x. And then after that, we will subtract 40 degrees minus 26 degrees is equal to 14 degrees, equals 1 half x. And then to solve for the value of x, we will divide it both sides by 1 half. So 1 half divided by 1 half is equal to x. And then 14 divided by 1 half is equal to 28 degrees. So the measure of arc DE is equal to 28 degrees. Now let us find the measure of angle ECD. So what is the measure of angle ECD? So if the measure of angle ACB is equal to 40 degrees, the measure of angle ECD is also equal to 40 degrees because vertical angles are congruent. So let's have our third example. So we have a given circle. The measure of arc NB, the bigger arc, is equal to 107 degrees. The measure of arc AM is equal to 19 degrees. We will find the following measures. We will solve for the measure of angle AXM and also the measure of angle NXB, this angle, the measure of angle MXB, this angle, and the measure of angle AXN, this angle. So let's find first the value of angle AXM. So we will construct the formula to solve for the value of angle AXM. We have angle AXM is equal to 1 half times the quantity of arc NB plus arc AM. Then we will substitute the corresponding value. So we have angle AXM is equal to 1 half times the quantity of the value of arc NB is equal to 107 degrees plus the value of arc AM is equal to 19 degrees. And then we will simplify. Bring down angle AXM is equal to 1 half. 107 plus 19 is equal to 126 degrees. And then 1 half times 126 degrees is equal to 63 degrees. So the measure of angle AXM is equal to 63 degrees. Now let us find the measure of angle NXB. So if the measure of angle AXM is 63 degrees, then the measure of this angle NXB, is also equal to 63 degrees because vertical angles are congruent. Now let's solve for the measure of angle MXB. So to solve for the measure of angle MXB, so since this is supplementary, then the sum of the two angles is equal to 180 degrees. We will just subtract the value of angle AXM, which is 63 degrees, by 180 degrees. So 180 degrees minus 63 degrees is equal to 117 degrees. So the measure of angle MXB is equal to 117 degrees. So how about the measure of angle AXN? So if this angle MXB is equal to 117 degrees, then the measure of angle AXN is also equal to 117 degrees because vertical angles are congruent with each other. So let us now apply algebra with our topic. So we have a given circle. So the value of arc AC is equal to quantity 3x plus 18 degrees. The value of arc DV is equal to quantity x plus 10 degrees. And the value of angle 1 is equal to 80 degrees. So we will solve for the value of x. the measure of arc AC, the measure of angle 2, and the measure of arc DB. So let's have the solution. So let's now construct the formula. So let's find first the value of x. So we have angle 1 is equal to 1/2 times the quantity of arc AC, the intercepted arc, plus arc DB. And then we will substitute the corresponding value. The value of angle 1 is equal to 80 degrees equals bring down 1/2 times quantity 3x plus 18 degrees plus quantity x plus 10 degrees. And then we will simplify. Bring down 80 degrees equals bring down 1/2 and then combine like terms. 3x plus x is equal to 4x. 18 plus 10 is equal to 28. And then bring down 80 degrees. 1/2 times 4x is equal to 2x. And then 1/2 times 28 is equal to 14. And then bring down 2x. Transpose positive 14, it will become negative 14. So 80 degrees minus 14 degrees is equal to 66 degrees. And then after that, we will divide this both sides by 2x. So 2 divided by 2 will be equal to x. And then 66 divided by 2 is equal to 33. So the value of x is equal to 33. And then after that, let's solve for the value of angle 2. So since this is supplementary, we will just subtract the value of angle 1, which is 80 degrees, by 180 degrees. So 180 degrees minus 80 degrees is equal to 100 degrees. So the measure of angle 2 is equal to 100 degrees. Now let us solve for the value of arc AC. To solve for the value of arc AC, we will use the equation 3x plus 18. Then we will substitute the value of x. So the value of x is equal to 33. So 3 times 33 is 99 plus 18 is equal to 117 degrees. So the measure or the value of arc AC is equal to 117 degrees. And then to solve for the measure of arc DB, we will use the equation x plus 10. Then we will substitute the value of x, which is equal to 33. So 33 plus 10 is equal to 43 degrees. So the value of arc DB is equal to 43 degrees.